Hello my dear learners, welcome back. Today in this video, we would start with question number 8 and end with question number 9. So from exercise 5.1 complex numbers. So before we start off with these two problems, we would require some basic identities which we have already done in lower grades, basically in your 8th standard and 9th standard. So those identities which you are already aware of, a plus b whole square, a minus b the whole square, a plus b the whole cube, a minus b the whole cube, and the last one would be a plus b into a minus b. So that identity we are any which ways using from the first video of this particular chapter. So let us make a note of all these identities and then we would proceed with the question. So I have a plus b the whole square is equal to a square plus b square plus 2ab. Next, a minus b the whole square is equal to a square plus b square minus 2ab. Then a plus b the whole cube is equal to a cube plus b cube plus 3ab into a plus b. So if you are finding this identity difficult, I will expand the bracket to get it in terms of a cube plus b cube plus 3a square b plus 3ab square. So our identity a plus b the whole cube can be written in two forms. Okay. Next I come to a minus b the whole cube. This can be written as a cube minus b cube minus 3ab into a minus b. Further, this identity can be written as a cube minus b cube minus 3a square b plus 3ab square. So these identities are very important, my dear learners, for especially question number 8, 9 and 10. So as of now, we will be doing in this video only question 8 and question 9. But if you make a note of these identities, it would be very helpful. And the last identity would be a plus b into a minus b is equal to a square minus b square. So you have 1, 2, 3, 4, 5 identity. Identity number 3 and identity number 4 are the same identities, but it has two different variations depending upon the approach of the problem. Any identity you want, you can substitute the problem, the values of a and b in. So we will start off with question number 8. So before that, if you all have made a note of it, it would be better. I will just erase the board first because I need a little space, bigger space actually. Okay. So now, 8th question, we already know any complex number should be of the form z is equal to 1 plus I to the power 4. Now 1 plus I to the power 4, can I write this as 1 plus I the whole square whole to the power 2? Please think. In my previous videos, we have come across set of indices, correct? So which property am I using here? A to the power m whole to the power n is equal to a to the power m into n. So when I multiply, see here I have I square whole to the power 2. So when I multiply 2 into 2, am I getting back I to the power 4? Here I have 1 plus I, but here I am just telling you how it goes. So when you understand, you have I to the power 4. So are you getting back the previous step? Yes. So here whatever operation you do should always resemble back your previous step. Otherwise whatever you do will obviously be wrong. So this can be written as, now the term inside the bracket 1 plus I the whole square resembles a plus b the whole square formula. So what is a plus b the whole square? A plus b the whole square equal to a square plus b square plus 2ab. Substitute inside the formula. Now this is my formula. Now substitute the value of A and B inside the formula. So I have, from this I have A is equal to 1, and from here obviously I have B is equal to I. Now you would ask me, while writing it in the form of complex numbers, I do not take the value of I, but in the formula I am substituting the value of I. See, my dear learners, very easy. When I have A plus B, it is an identity. So when I consider my identity here, whatever term is given will be substituted as A and B itself, right? The first term will be considered as A and the second entire term will be considered as B. This is applicable only when I am substituting inside the formula. Rest all steps will be the same if I use complex numbers. Okay. So now my A value is 1, B value is I. So when I substitute inside the formula, this will resemble A square. What is A square? 1 square plus B square is I square plus 2 into 1 into I. Okay. Yet our problem is not over. We have just substituted the value for A plus B the whole square. But you have a whole square here as well. So therefore this can be written as entire bracket the whole square. Hope you all have followed. Now if I simplify the bracket, I get this as 1 plus I square. We know it is equal to 1 in complex numbers. So this is minus 1 plus 2i the whole square. Now if I expand the bracket, I get this as 1 minus 1 plus 2i the whole square. Plus 1 minus 1 will get cancelled. Then what would be my final answer? So again, I'll just resume my steps this side. So I have 2i the whole square. This can be written as 4i the whole square. Correct? Now I square can be written as, how did I get 4i? Now 2i the whole square can be written as 2 square into I square. Okay? So 2 square is 4. I square I have just written. So I square, if I substitute the value as minus 1, I will get the value, the entire value of the question to be equal to minus 4. My final answer is minus 4. But does it resemble z is equal to a plus ib? No, it does not resemble. So when it does not resemble in the form of a plus ib, what do? If I do not have an imaginary term, I will always consider it to be 0. So therefore, your final answer is z is equal to minus 4 plus 0i, where a is equal to minus 4 and here I have b is equal to 0. Hope you all have followed. We have just used a very basic identity in this particular problem, but while you bifurcate, before I use the identity, I use theory of indices. So hope this concept is clear to you. If not, please pause the video, resume it wherever you want it from, and then understand each and every step and then only proceed. Because we all know, my dear learners, that concept is our strength. Okay, I hope you all have understood question 8. Now moving to question number 9. My question number 9 is 1 by 3 plus 3i whole cube. So obviously this resembles a plus b the whole cube formula. So in my, just before I started with question number 8, I gave you all set of identities. So can I write this in the form of a plus b the whole cube, which is nothing but a cube plus b cube plus 3ab into a plus b? Yes. Or you can also write it in the form of a cube plus b cube plus 3a square b plus 3ab square. So from this I have a is equal to 1 by 3, b is equal to 3i. But what have I told you all? Whatever question on complex number is given to us, please denote it in the form of z. Write it as z and then only proceed with each and every Now we would substitute in our identity. So further this can be written as a cube 1 by 3 the whole cube. Now this is my z plus 3i the whole cube plus 3 into a is 1 by 3 into b is 3i inside bracket 1 by 3 plus 3i. Okay, next 1 by 3 the whole cube is 1 by 27 plus 3 cube is 27 into I cube. Next, since the terms are getting multiplied here, 3 and 3 gets cancelled. I have a plus sign. Then I have 3i into bracket 1 by 3 plus 3i. Now further if I simplify, I have the value of I cube to be substituted. Now I cube can be written as I square into I. Yes, for people who do not understand how do I do it, please see my previous videos wherein I have explained in detail to find out the values on powers of I. Okay, so I square we know the value is minus 1 into I which is equal to minus I. So therefore I cube is equal to minus I. I will substitute. So 1 by 27 minus I is nothing but minus 27i plus, I will expand the bracket, 3i divided by 3 plus 3i into 3i will give me 9i square. Okay, again here 3 and 3 will get cancelled. Now here I can again substitute the value of I square as minus 1. So this can be written as 1 by 27 minus 27i plus 9 into minus 1. I hope each and every one of you all are able to follow. Next, I will resume my steps here. Now this can be further written as 1 by 27 minus 27i plus I is nothing but minus 26i plus into minus will be minus, you have a 9. Okay, I have a 9. So this can be written as real terms with real terms, imaginary terms with imaginary terms. So I get this as 1 by 27 minus 9 minus 26i. Now what should I do, my dear learners? I have to find out my LCM. So how do I find out my LCM? My denominator, entire denominator should be 27. So my first value will be 1. Now what will I do? I will cross multiply it with 9. So when I cross multiply 27 into 9, 27 into 9, 9 sevens are, yes, think and write the answer. 63. So 63. 9 twos are 18. 18 plus 6, 24. So I get this as 243 minus 26i. Now 1 minus 243 will be equal to minus 242 divided by 7 minus 26i. So does this resemble z is equal to a plus ib format? No, because I have a minus sign in between. Since I have a minus sign in between, this can be further written as minus 242 divided by, this is 27 divided by 27 plus into bracket minus of 26i. So therefore this entire value is equal to a and b is equal to, this is minus 26i and here b is equal to minus 26. Hope all my learners have understood. Only thing what I still feel is people who have difficulty in finding out LCM, please comment and let me know so that I could make you all videos on LCM. If not, if you're able to follow, well and good. It helps me. Please comment and tell me if you're able to follow, if you're finding these videos informative. Anything and everything is welcome. I will take it positively. But my main motto is all my learners should understand each and every point whatever I teach, because these are all very, very, very important when you go to higher grades. These are all your basics. Basically, when you do data science, basically, when you do your higher grade engineering, mathematics, degree, anything for that matter, when your basics are strong, you can build any amount of any big building based on your basics, right? So if your strength is your concept, then any variety of problem can be overcome. So please, my dear learners, each video I keep telling, please become very strong towards your concept. Then I tell you, everything will be a cakewalk. Stay tuned for more questions. Thank you all.